This is a physics digital story that I've called Winning the Game with the Right Kick by Andrew Michael Ajak. It involves using the big three kinematic equations to solve the right velocity and the right angle in order to place a kick exactly where you want it to. So here's the situation. You've taken the lead by 2. There are 3 seconds left on the clock. You gotta kick it off. What are you going to do? Well, let's do some brainstorming. Here's the field. Now, our team needs 4 seconds to get downfield, so we need the ball to be airborne for 4 seconds. If we kick it in the end zone, it'll be a touchback. That means they're going to get the ball at the 20. They'll have a shot at our end zone, and it won't kill any time on the clock. If we kick it too short, they can return it for a touchdown, and then we lose the game. There won't be any time left. If we kick it towards the sidelines, it risks going out of bounds, and then we have a penalty. So, what's our strategy? So, what do we got to do? First, we got to put the ball in the air for 4 seconds. Second, we don't want to risk kicking it out of bounds, so keep it centered. That's good. That'll make the physics easy. Third, we want to put it past the 20-yard line. But fourth, we don't want to kick it in the end zone. So how about the 10-yard line? That'll give our kicker a little bit of leeway. Kicks it a little bit too hard, go between the end zone and the 10. A little bit too weak, between the 10 and the 20. Okay, so let's get our data together. The change in the X position. We kick the ball off from our 30-yard line, and we want to put it on their 10. That's a change in 60 yards. We need to move the ball 60 yards up the field. What about the Y position? Well, it's going to start on the ground. It's going to finish on the ground. So 0. Yeah, it's going to go in the air, but it doesn't matter. We only care about where it starts and where it finishes. And it's going to start on the ground and finish on the ground. We've already said we need 4 seconds. And this is Earth, so of course the acceleration due to gravity is always 9.81 meters per second squared. The next thing is our 60 yards we need to convert into meters. 60 yards times the conversion factor of 1 meter per 1.09361 yards will come out to be about 54.86 meters. Let's sort it all out into our XY table. Our initial starting position is 0, 0. Our ending position is 54.86, 0. We know nothing about velocities in either directions. That's okay, that's what we're going to end up solving for. There is no rocket strapped to the football, of course, so there is no x direction velocity, but it is under the influence of gravity, so the acceleration in the y is negative 9.81, and the time that it'll travel for is 4 seconds. So what do we need again? How fast we need to kick the ball, and then at what angle, because that'll play a role. So, here's the data again. Let's go ahead and take a look at our big three and see what we can do with it. Now we want the initial velocity for the x direction. We'll use the kinematic equation x equals x initial plus v initial t plus 1/2 at squared. Remember, the acceleration is 0. That's great because the 1/2 at squared term gets wiped out. Now, let's plug in our values. The final x position is 54.86, the initial is 0, and the time is 4 seconds. That means the velocity is 13.72 meters per second in the x direction. Let's remember, this is the x direction's velocity only. We still need the y direction. So once again, what do we need? How fast do we need to kick the ball, and at what angle? Now we need to get the y direction initial velocity. We've gone ahead and updated the table. Since the acceleration in the x direction is 0, both the initial and final velocities for the x direction will be the same. Y direction velocity. Same strategy, except now we're using y values. 0 equals 0 plus v initial times 4 plus 1/2 times negative 9.81 times 4 squared. The 1/2 times negative 9.81 times 4 squared turns into a negative 78.48. We'll move that to the left side of the equation, and then we will divide by 4. Therefore, 19.62 meters per second is our initial y direction velocity. We now have both components of the velocity. Now we got to use the Pythagorean theorem. The reason being, the x and y components of velocity cannot simply add up. They have to be added up like they would in a right triangle, so we use Pythagorean's theorem. 13.72 was the initial velocity in the x. 19.62 was the initial velocity in the y. Using Pythagorean's theorem, we can find out the net initial velocity. The net initial velocity squared is 573.18. If we take the square root of that, we will get the initial velocity, and that is the initial velocity altogether, incorporating both the x and y components, is 23.94 meters per second. Now we have the velocity, but we need the angle as well. We can use trigonometry to figure that out. Using SOHCAHTOA, we can use the tangent rule. The tangent of theta equals the opposite side divided by the adjacent side. That is to say, the tangent of theta equals 19.62, the side of the triangle that is opposite of theta, divided by 13.72, or the side that is adjacent to theta. If we do the inverse tangent of that fraction, we will get 55.04 degrees. So the answer, we have to kick the ball with a velocity of 23.94 meters per second and a 55.04 degree angle to the field. If we kick it a little bit too fast, it'll go between the end zone and 10. Kick it a little bit too slow, between the 10 and the 20, but it'll still land in our target range. So now, it's up to the kicker. Well, thank you for watching. My name again is Andrew Michael Ajak, and this was Making the Right Kick for a physics equation for a digital story. Creds will come up and be on for 10 seconds.